Welcome to our latest video on the topic of isomers. This video is suitable for GCSE students. By the end of this video lesson, you should understand that isomers have the same molecular formula but a different structural formula. You should also be able to explain the difference between chain and positional isomers and be able to list examples of these. And finally, you should be able to name and draw structural formulae for isomers of hydrocarbons with up to 5 carbons and alcohols with up to 4 carbons. Now, isomers are groups of compounds that have the same molecular formula but different structures or arrangements of atoms. Now, the molecular formula simply tells you the number of each type of atom present. So, for example, if we take the molecule ethanol, which we know has a chemical formula of C2H5OH, its molecular formula will be simply C2H6O. And this is because there are 2 carbons, 6 hydrogens and 1 oxygen in every molecule of ethanol. Now, you will often come across the term molecular formula when studying the topic isomers and attempting past paper questions. Examiners will often use this term and then ask you to draw possible structures of molecules that have this molecular formula. Now, at GCSE, the types of isomers you will come across are called chain and positional isomers. Now, these 2 types of isomers are both examples of structural isomerism. The molecules that exhibit this form of isomerism have the same molecular formula but different arrangements of atoms, different structures. That's why they're types of structural isomer. Now, in chain isomerism, the isomers have different carbon chains. In other words, the length of the carbon skeleton differs. They possess the same functional groups and belong to the same family or homologous series. For example, a compound with a molecular formula C4H10 has 2 possible structures. It could be butane, which is CH3 attached to a CH2 attached to another CH2 and a CH3, or it could be 2-methylpropane, where the longest continuous chain is 3 carbons and there is a CH3, a methyl group, on the second or middle carbon. Now, these 2 compounds are isomers of each other because they have the same molecular formula, C4H10. They both have 4 carbons and 10 hydrogens. However, they have different arrangements of atoms. Their structural formulas are different. Now, because the shapes of these molecules are different, you'll often find they have different physical properties. They have different boiling points because they don't fit together in the same way. Now, the second type of isomerism you're going to come across at GCSE is positional isomerism. Now, here, the functional group, the part of a molecule that determines its chemical reactions, is in a different position, but we have the same carbon skeleton, we have the same length of carbon chain. So here we have butan-1-ol, 4 carbons long is the chain, and the OH group is on carbon 1, and it's an alcohol. Now, the functional group is an OH group, because that's what determines the chemical reactions of alcohols. And if we move the OH to a different carbon on this carbon skeleton, we have butan-2-ol. And this is the isomer where the OH group is on carbon 2. Now, they're classed as isomers because the molecular formula is the same. However, their arrangement, their structures, are different. So, butan-1-ol, butan-2-ol both have 4 carbons, 10 hydrogens and 1 oxygen. However, these atoms are arranged differently. That's why they're classed as isomers. This is a positional isomer because the functional group, the OH group, is on a different position in the carbon chain. Now, it's not just alkanes and alcohols that have isomers. You've also studied alkenes. Now alkenes are hydrocarbons, compounds that are made up of hydrogen and carbon only, that contain a carbon-carbon double bond. And here we have two alkenes with the same molecular formula, C4H8. They are isomers of each other because they have the same molecular formula, the same number of carbons, the same number of hydrogens, but they have different structures, different arrangements of atoms. Now these are also classed as positional isomers because the functional group here, the part of a molecule that determines its chemical reactions or properties, is the carbon-carbon double bond. Now in butanene, the carbon-carbon double bond is between the first two carbons, carbon 1 and 2. And when naming alkenes, you always number the carbons starting at the end nearest the double bond. So the double bond is between carbons 1 and 2, and when naming it, we go for the lower number, so we call it butanene. Now in the second molecule here, butanene, the carbon-carbon double bond is between carbons 2 and 3. And therefore, we always go with the lower of the two numbers, so it's called butanene. Now, butanene and butanene are isomers of each other, and they're positional isomers because we've moved the carbon-carbon double bond to a different position. In the first molecule, it's between carbons 1 and 2, and in the second molecule, it's between carbons 2 and 3. They're positional isomers. Now, there's one other isomer with a molecular formula C4H8 that's an alkene. And you might think that all you have to do to draw this is just move the carbon-carbon double bond one more carbon along. So in other words, put it between the last two carbons. Now if you did this, you would be wrong, because this is exactly the same as one of the isomers we've already drawn. Now to name an alkene, we have to number the carbon chain that's the longest, and you can see the longest carbon chain here has 4 carbons in it, and we start at the end nearest the carbon-carbon double bond. And if we do this, the double bonds between carbons 1 and 2, we go for the lower number, and once again it's butanene. So that would be incorrect as the other isomer. So because there's 3 isomers with the molecular formula C4H8 that are alkenes, we now need to look to see if there are any chain isomers. So that means we need to cut down the length of the longest carbon chain. So to do this, I'm going to draw an alkene with a longest carbon chain of 3 carbons. And I'm going to put in my double bond. And if I do this, I've got to remember that there needs to be a CH3 added onto this chain. Because remember, I need a molecular formula of C4H8. So to do this, I've drawn my 3 carbons in the longest chain, and I'm going to put my CH3 group in the middle of the chain. And therefore, that compound would be a substituted propene molecule, because an alkene with 3 carbons is called propene. So to name this molecule, I number the longest chain, starting at the end nearest the double bond. And you can see that the longest chain has 3 carbons. And on carbon 2, we have a CH3 group. And a CH3 group is called a methyl group. So this compound is called 2-methyl propene. And it's an isomer of the other 2 compounds, butanene and butanene. And we have a chain isomer here because the longest carbon chain is a different length. In the first 2 molecules, but1 and butanene, the longest carbon chain is 4 carbons long. In 2-methyl propene, it's 3 carbons long. Now all 3 of these molecules have 4 carbons and 8 hydrogens in their structure. They're all isomers because they have the same molecular formula, but a different arrangement of atoms, a different structural formula. Now when we draw out the structures of molecules, we call it the structural formula, or sometimes at GCSE they refer to it as the displayed formula. Now you might be wondering why I've not called this molecule 2-methyl-prop-1-ene. Now if you called it 2-methyl-prop-1-ene, you would get the mark in the exam. However, most chemists won't use the term prop-1-ene because the carbon-carbon double bond can only be between carbons 1 and 2. Wherever I draw the carbon-carbon double bond, when naming the molecule, I start numbering nearest the double bond, and the carbon-carbon double bond will always be between carbons 1 and 2. So therefore there is no prop-2-ene, so you can just call this molecule 2-methyl-propene. So now let's test your understanding of what we've learnt in this video with some practice questions. Here's the first practice question, and this first question is in two parts, part A and part B. So here's part A. Read through the question, pause the video, and then we'll show you part B, and then we'll go through the answers to both parts A and B. So here's part B. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers to parts A and B. So in question 1A, you're told that an alcohol has a molecular formula C3H7OH, and then you're told to give the structural formula and names of the two isomers of this alcohol. So the first isomer will have a carbon chain of 3 carbons in it, because remember it's C3H7OH, and we'll put the OH group on the first carbon. Now when drawing an alcohol, although there's a bond between the O and the H group of the OH group, most chemists will not bother putting this in, and it's common just for you to write OH. And to name the alcohol here, I have to number the carbons starting at the carbon next to the OH. And when I do this, the OH is on carbon 1. So this alcohol is called propan-1-ol because there's 3 carbons in the alcohol. So it starts with prop, and the fact that it's on carbon 1 is the reason it's called propan-1-ol. Now the second isomer here is a positional isomer where the OH group is on carbon 2. So I'm going to put all the carbons and hydrogens in here now. Now this isomer has the same number of carbons, hydrogens and oxygens as propan-1-ol, and it's called propan-2-ol because if I number the carbon chain and I start at the end nearest the OH group is on carbon 2. And you can see it doesn't matter which way I number it, the OH group is on carbon 2 here, and that's why it's called propan-2-ol. So this question is worth 3 marks. There's 1 mark if you drew the structure of propan-1-ol correct, 1 mark if you drew the structure of propan-2-ol correct, and 1 mark if you had both names correct. Now I just want to point out one more thing here. Now the molecular formula is simply the number of carbons, hydrogens and oxygens present. Now the reason in this question they've said C3H7OH instead of C3H8O is they're trying to help you to remember that alcohols have OH groups. That's why they've written it in that way. So for part B, the question says C4H10 has 2 isomers. The diagram below shows the structure of one of the isomers, butane. Draw and name the other isomer, and it's a 2-mark question. Well, when drawing isomers of alkanes, you have to remember there's no functional group, so you can't move the functional group to a different position. It doesn't have a carbon-carbon double bond, it doesn't have an OH group. So all you can do when drawing isomers is to draw chain isomers, reduce the length of the longest carbon chain. So if I draw 3 carbons in a line, I have to remember here that I have to find a space for a CH3 group because this molecule has C4H10 as its molecular formula. So I'll put the CH3 group on the middle carbon, and if I want to name this, all I do is I number the chain and I want to find the longest continuous carbon-carbon chain. So it has 3 carbons in it, so it will be something propane. And the CH3 group, which is called a methyl group, is on the middle carbon, which is carbon 2. So this is called 2-methyl propane. And we normally put a hyphen between a number and a word. So that's why we've written it as 2-methyl propane. Now it doesn't matter which way you number the carbons. However you do it, the methyl group will be on carbon 2. So that's why this compound is 2-methyl propane. And if you drew the structure correct, you get 1 mark. And if you named it correct, you get the 2nd mark. So here's our second practice question. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So now let's go for the answers. Now our molecular formula is C5H12. And because the number of hydrogens is double and add 2 compared to the number of carbons, it has to be an alkane. So the obvious thing to do first is to draw the straight chain alkane that's got 5 carbons in. And that would be pentane. And pentane would have 5 carbons and 12 hydrogens. Now, the second compound I'm going to draw has to be a chain isomer. It can't be positional because I don't have a functional group in an alkane, so I can't move it to a different position. So all I can do is cut the chain length down. So my longest chain here is 4 carbons. That's 4 in the longest chain. So therefore I have a CH3 group that I can put as a subchain. So if I put this on carbon 2, the compound is named 2-methyl butane. Now it's always useful to name the isomers that you draw because every unique isomer will have a unique name. If you end up having the same name, you've drawn the same isomer twice. So in my next example, I can't put the CH3 group on a 4 carbon chain anywhere else than on the 2nd carbon. Otherwise I'm just drawing the same compounds. I'm either drawing pentane or 2-methyl butane again. So all I can do really is cut the chain down to 3, and then I have 2 CH3 groups to put in. So if I put them on the middle carbon, that would be called 2,2-dimethyl propane, because a alkane with 3 carbons in is propane. Now all 3 isomers have the same molecular formula, that is C5H12. They're chain isomers of each other because the carbon chain is different for each of them. And you can see for all these isomers there are 5 carbons and 12 hydrogens in each. So the molecular formula is C5H12. So here's our last practice question. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers to parts A and B. So question 3 says butan 1-ol and 2-methyl propan 1-ol are isomers with the molecular formula C4H10O, and it draws the structural formula of butan 1-ol and 2-methyl propan 1-ol here. And question A says explain the meaning of the term isomer. Is a 1 mark question. Well, isomers have the same molecular formula but different structures. So if you said that, you get 1 mark. You could say different structural formulas. That would be fine as well. Now for question 3b, it says 2 other isomers that are alcohols exist with the same molecular formula, C4H10O, and it says draw the structural or displayed formulae of each of these 2 isomers and name them. So for this question, we need an alcohol with 4 carbons in, and it must have 10 hydrogens and 1 oxygen. So here are the 2 possible structures here. Now this time I've put a bond between the O and the H, but you don't need to. And I'm going to name my first isomer here. So I always number the chain nearest the OH group. So you can see it's numbered right to left here, and the OH group is on carbon 2, so it's called butan-2-ol. And then for my next isomer, I'm going to number the longest carbon chain, and the longest continuous chain has 3 carbons in it. Now this time we have a CH3 group, a methyl group, and an OH group on carbon 2, and it doesn't matter if we number them left to right or right to left, they're still on carbon 2. So this is called 2-methyl propan-2-ol, and it's called propan-2-ol because the OH group is on carbon 2, and it's called 2-methyl because we have a CH3 group on carbon 2. There's 1 mark here for getting both structures drawn correctly and 1 mark for naming them correctly. So it's a 2-mark question. So that concludes this video lesson. So after watching this video, you should now understand that isomers have the same molecular formula but a different structural formula. You should be able to explain the difference between chain and positional isomers and be able to list examples of these. And finally, you should be able to name and draw structural formula for isomers of hydrocarbons with up to 5 carbons and alcohols with up to 4 carbons. So that concludes this video lesson. So please check out our YouTube channel, Dr. O Chemistry, which has lots of GCSE, AS and A-level videos, and our Twitter site @RadaChemistry.